Let's look at some more examples of vector addition. Say vector A is such that the magnitude is 12.5 and the direction is 23 degrees. Vector B is away here in the second quadrant. The magnitude of B is, let's call it 10. And the direction, because it's in second quadrant, it's between 90 and 180. Let's say it is 150 degrees. And the problem is to find R, which is A plus B. So going stepwise. Step 1, break into components. So you have AX is going to be 12.5 cosine 23 degrees. AY 12.5 sine 23 degrees. BX 10 cosine 150 degree, and BY 10 sine 150 degree. Equals. Let's find what they are. 12.5 cosine 23 is 11.51. 12.5 sine 23 is 4.88. 10 cosine 150 is negative 8.66. 10 sine 150 is 5. Now here, this is negative because if you look at the components of P, then the x component is on the negative x-axis. Right, so to be more accurate, let's just call this the vectors instead of magnitudes, because x is just 0 degrees and y is 90 degrees. Step 2, find Rx and Ry, which is adding the horizontal vectors together and adding the vertical vectors together. So Rx is Ax plus Bx. In this case, it's going to be smaller, 11.51 minus 8.66, 2.85. Ry is Ay plus By, 4.88 plus 5, 9.88. And last, our step 3 is recombine Rx, Ry to get R and angle of R. So in this case, Rx, this magnitude by Pythagoras theorem is going to be Rx squared plus Ry squared. So you plug that in, square root of 2.85 squared plus 9.88 squared, 10.28. And the angle is going to be tan inverse of Ry over Rx. Tan inverse of, where's Ry? Oh, 9.88 divided by 85. Oh, I pressed tan. So tan inverse of 9.88 divide 2.85. 73.91 degrees. So this is still in quadrant 1. And the last step is complete the diagram. And how you can do that, because these diagrams are not precise, you need this information before you can draw, because this parallelogram could end up being in the second quadrant, right? But in this case it ends up being in the first quadrant with an angle of 73.91 degrees. And you can see that the x value is small, right? That's because if you look at the x component, this vector pushes to the right, this vector is pulling to the left, so they cancel each other out, and so the x value is lower than either of the values because there's a subtraction. Okay. I think I'm going to make another video with an example where this goes into another quadrant. So one more video after this.